Okay, 7b, let's do this. Where is it? Here we go. Nope, that's not it. Here we go. So now we're going to determine the value of theta that will maximize the area of the window. So we've already got this. Like I was saying before, if you couldn't get here, that's fine. Once you're here, all you need to do is know that the area will be maximized when it's equal to 0. So if it's like this, I'm looking for the stationary points. If I end up with 2 of them, I'm just going to test it on the graph by substituting the x values back in to find out which one's higher. Your other option is to test the second derivative and work out which one is increasing. So if I look at the second derivative and I input any value between like here and here, then here it would be positive, here it would be positive, here it would be positive for the second derivative. Whereas like down here it would be negative, and then negative, and then negative. So you get the idea there. Now I'm going to scroll down. They've given like 3 pages of working for this, which is your first hint that this is going to be a bit of a tricky trick one. So first thing I'm going to do is state that formula that they gave me so I don't forget it. And it was A is equal to 4 sine theta cos theta plus 4 sine theta. Okay, so when I take the derivative of this, I'm going to let this first part equal u and this part equal v, and then it's just product rule. So u equals 4 sine theta. So u dash equals 4 cos theta. V equals cos theta. So then v dash equals minus sine theta. Don't forget this guy when you derive as well. He always feels lonely. Okay, so A dash is equal to this one times that one. Minus 4 sine. Now, sine times sine will make sine squared. I don't know why we write it like that instead of having brackets. You know, it's just one of those things that we just do. So that times that gives me that. Plus this one times that one. So 4 cos squared theta. Plus, now I'm going to take the derivative of this n bit because I'm not going to forget him. 4 sine goes to cos, so cos theta. Okay, so that's where we're at the moment. Now, I've got squared here, and this guy there. So I know this little trick. Now, some of you may have seen this in the methods textbook. If you do the double up, you've definitely seen this. We have another formula that's called the Pythagorean identity. So that's sine squared theta plus cos squared theta. So if I can match some of this, I can change it in. Now, see how this one's cos and that one's cos? I'm going to change it to get it in terms of cos, because that way I can knock out this sine and then it's probably going to turn into a quadratic, because everything is a quadratic. So sine squared theta is equal to 1 minus cos squared theta. This is on your formula sheet too. You need to look at it and get familiar with it so you know what's what and what's where. Okay, so I'm going to substitute this in. Now, first thing I'm going to do, I'm going to factorize. I'm going to factorize negative 4 out because I'm sick of writing all of these 4s. So 1 minus cos squared theta, bracket. Now, because I factorized the negative out, this is going to change into a negative because that became positive. So minus 4 cos squared theta. All right, get rid of you, sucker. Minus cos theta. Okay, so now all I have to do is group my like terms. Minus 4 bracket. Okay, so now I've got this one and this one are like terms. Whee. So that'll become minus 2 cos squared theta minus cos theta plus 1. And we're going to make that equal to 0 because that's how I find my stationary points. So next thing I can do is take this across by division. 0 divided by anything is still 0. So we've got 0 is equal to minus 2 cos squared theta minus cos theta plus 1. Now I'm looking for two numbers. Like I can see here, it's turning into a quadratic. So I've got two things. It's got to multiply to give me negative 2, which is this number times that number. It's got to add to give me negative 1. So the factors that will do that will be, it's 2 and 1. Which one needs to be negative? You need to be negative. Okay, so now I'm going to factorize this. Now remember, when you factorize, you're breaking this down into its two components, and then we're going to factorize again. So minus 2 cos squared theta minus 2 cos theta plus 1 cos theta plus 1. Okay, so for this one, I can take out a negative 2 and a cos theta. That's going to leave me with cos theta plus 1. And over here, I can see it's already perfectly in that form, but I'm still going to factorize a 1 out because I have to take something like that. Now I can group this one and this one to make my new bracket. Okay, and cos theta plus 1. Okay, from here, null factor rule. So let each bracket equals 0 and rearrange to solve. Plus 1. Take the 1 over first, it'll become negative 1. Then I'm going to divide it by the negative 2, and I'll be left with cos theta. So now I want the value for cos where it's equal to positive 1/2. So, yeesh, that didn't turn out well. Okay, cos is positive in this quadrant and this quadrant. The value that gives me 1/2, and I'm thinking about this with my hand trick. Oh, that hand not so good. Okay, if it's cos, then we're looking in this direction. I'm going to have one finger up, so then I'd put this finger down. So this is my 60-degree finger. Okay, or I could say that theta is equal to pi on 3. Okay, the other one is if it's down here, I could say that's minus pi on 3. Okay, next value that we're going to try, we're going to let the other bracket equal to 0. So 0 equals cos theta plus 1. So then we want the values for cos where theta is, we want the values for cos theta equals negative 1. So they are the values over here on our unit circle, meaning that theta must be equal to pi here, or negative pi. Now, we were given a domain. What was that domain? So it can be between 0 up to 90 degrees. So, pi, you're out. So this one is not in our domain. See you later. Must be this one. Now this one is also out of our domain. So therefore, theta equals pi on 3. Now, I believe it asks you to do something else. So let's go back and read the question, because they've given us a lot of space, which means there's probably something else we need to do. Determine the value of theta that will maximize the area of the window. Look, I believe that we have found the area of theta that will maximize the area of the window, but this word in maths, especially in methods, normally alludes to having to do this to test the values for the maximums. So let's give it a red hot crack. We've got the time. Okay, so we worked out that what did we work out? This was the derivative, which means I just really don't want to. Okay, so I guess I could test it using a different method. If I know that this is a root, I just don't want to take the derivative again. It's a lot of work. Okay, so that one or that one. There's my point. There's my point. So I've determined that this is a maximum value at pi on 3, or it's down here at pi on 3. Now, if I want to prove that this is going to a maximum, I need the gradient to be increasing on this side and decreasing there. If it's decreasing and then increasing, then it's going to a minimum. So we can just substitute in some values. So up here, we're going to have our angles. Here is pi on 3. And at that point, we know our gradient is equal to 0. Okay, so we're going to pick a value before it, 0, and a value after it, pi, yeah, whatever. Nah, we'll do pi on 2. That's slightly bigger because that's like 60 degrees, that's 90 degrees. Okay, so all I have to do is substitute these values back into my original expression and that'll give me what I want. Now, I'm going to choose to substitute them in here because I've already factorized it. I know this is a pretty easy looking one. So that's still where we found out that our value here, the derivative, should be equal to this. It would still have a negative 4 in front of it, but it's not going to have too much of an effect. Okay, so negative 2 cos 0. Now, cos of 0 is 1, so that's negative 2 plus 1 is going to give me negative 2 plus 1. That whole term there is negative 1, and then that's going to be multiply. Cos of 0 is 1 plus 1, 2. So then that's going to be negative 2. That's not looking great for us. Okay, next value that we're going to test is this one here. Okay, so minus 2 times cos of 90 degrees is going to be 0 plus 1. And then we're going to have, so that'll just give me 1. And on the other bracket, we've got cos of pi on 2. I know what's happened because we factorized out a negative 4, which means whatever this is, we would really have to multiply it by negative 4, which would turn that into a positive 8. Okay, now I'm with you. Okay, so this is also going to have to get times by a negative at the end. Okay, so that's that. Now the next one, cos of 90 degrees is 0 plus 1, making that a 1, giving me negative 4 for my gradient there, meaning therefore true, as the gradient looks like this. Wee, max. Okay, there we go. Got there in the end.